Thanks for inviting me here today to talk about interactive visualization and VR experiences. So my name is Jose Lizardo. I'm a technical specialist at Autodesk. I focus primarily on 3ds Max and the 3ds Max family of products and services as it relates to visualization. So I do visit some game studios as well, use 3ds Max, but my sort of bread and butter or my area of focus is really around visualization and all forms of visualization. So I'm going to spend the next 40 to 45 minutes or so talking to you guys about some of our offerings in this area. So without further ado, let's jump right in. Just a quick look at my agenda. So we're going to focus a lot on 3ds Max and the interop with Stingray, the game engine. If you're not familiar with Stingray, it is a game engine much like Unity, much like Unreal, and it is our tool to create interactive and immersive experiences as well as virtual reality experiences. So we're going to take a look at that workflow between 3ds Max and Stingray. We're also, of course, going to talk about virtual reality. Then we're going to talk about Revit Live. So Revit Live is a tool, of course, for Revit. It is based on Stingray technology, so it's a game engine technology. And it's basically a one-click from Revit into a real-time immersive experience. So bypassing 3ds Max, bypassing Stingray, going straight into real-time. And then, of course, if you want to enhance or further embellish these projects, you have access to 3ds Max and Stingray to take it even further. If we have time, I might get into some infrastructure type examples, and then we're going to finish off with some reality capture workflows, all within the context, of course, of real-time visualization. So the first announcement that I want to make, if you're not familiar or if you're not aware of this announcement, this has happened about a month ago, but 3ds Max is now shipping and bundling with Stingray, the game engine. If you are an active subscriber of 3ds Max, or a collection which includes 3ds Max, and they all include 3ds Max, then you have access to Stingray for free. This is a pretty big deal. We're pretty excited about this. I'm super excited about this. And Stingray is now accessible to pretty much all of Max users or anyone on an active subscription. And this happened, like I said, about a month ago. The thing to note is that it is now been rebranded to Max Interactive. This is the exact same thing as Stingray, so don't get confused. Under the hood, nothing has changed in terms of the product or features. It is just now called Max Interactive. So I'm going to be referring to the product Stingray as Max Interactive going forward. All right, so speaking of Max Interactive, I want to show you guys a quick little video highlighting a pretty interesting visualization or an example of a visualization of this sort of interior architectural space here. So this is a model that originated in Revit, brought into Max, and then pushed into Stingray or Max Interactive. And I like to show this for two things. One, it looks really good. You can produce some really high quality rendering out of Stingray or Max Interactive. It's all physically based rendering, physically based shading. It's got pretty good light baking. It's got really good light baking and great effects like that. Don't mind the dancing smoking man. He's been there for a while. He's a sort of token of this apartment space. But so the other thing that I like to mention about this particular visualization is that one, it looks really good, but two, this is a fully interactive, fully immersive, fully explorable environment. You can go wherever you want. You can look at anything from any angle, from any vantage point, unlike a still image or a still sequence where you're kind of stuck to, fixed to a particular shot. As I approach objects that I can interact with, I get a nice little heads-up display that tells me that I can turn on and off certain things, therefore seeing how they adjust or see how they affect the overall scene. I can change materials, for example. This is just a couple of examples of the things you can do. This is how I've decided to program this experience, but this could be, multiple ways. There's multiple ways of doing this, many ways of going about these types of visualizations. So let's take a quick look at how this is all basically put together. This is the 3ds Max version of the scene that we just saw. And it's important to note, and I really want to underline this and bold and italic because this is a really big deal. This scene is a V-Ray scene. This originated from Revit, was brought into Max, and was rendered in V-Ray. Now, I'm sure that there's a lot of architects on this call right now, and a lot of you, if you're doing any kind of visualization, you are most likely using V-Ray. V-Ray is the go-to de facto industry standard in terms of architectural visualization, and Stingray or Max Interactive, I should say, supports V-Ray scenes. So this scene, like I said, is a V-Ray ready scene. We bring in the materials, we bring in the lights, and it all just comes in. right? So I'm going to showcase what I mean by that here. So if I just open up my material editor, you see that I have a bunch of V-Ray materials in this scene. They're set up with diffuse maps, glossiness maps, bump maps, roughness maps, all of that. So what we're going to do is go into the Stingray menu up on top. And this, by the way, now with Max Interactive will have changed. It's going to be called just Interactive and not Stingray. And we're going to go to Level Send All. This Level Send All dialog allows me to pick and choose the things that I want to send into the game engine. Here we have materials, texture maps, cameras, lights, and so on and so forth. The one that's really, really important to note is the last one on this list. So generate UVs for light baking. This is a pretty big deal. In the world of game engine technology or game engine workflows, it's all about baking, optimizing performance. And one of the things we do is we bake lighting. We don't calculate lighting dynamically. Of course, it wouldn't run at 60 frames per second. To bake lighting, you need to have a second set of UVs on all of your objects. Doing that manually is really cumbersome. With the workflow that we have here with Level Sync, with Max Interactive, it will automatically generate those UVs for you. Now, of course, the process of generating those can be a little bit long, but in the context or when compared to doing it manually, it's days saved of work. So we hit send. Of course, this is sped up quite a bit. This whole process of sending this whole scene took about an hour. But it's going to take every single asset, export it as an individual object, push it into Max Interactive. It's going to unwrap and create a secondary set of UVs all automatically. Again, an hour of work versus maybe a week's of work. And that is not a lie, because I've tried doing this in the past without these workflows, and it took days of work. So here we go. It's importing. You see a little progress bar at the bottom there. And what it's going to do, it's going to completely reassemble the scene inside of a level, inside of Stingray, or inside of Max Interactive. We can turn on camera tracking from 3ds Max, basically linking the camera views together. If I navigate in one product, I see the exact same viewing point from the other product, and vice versa. You see that all of my assets came in as individual objects, not one big blob of geometry. And they all have a corresponding pivot point that represents the pivot point of 3ds Max. So this is really, really good. If I want to make changes, move objects around, everything is very accessible and very easy to do so. I can make changes in the Max scene and push those over as well. Here we have a chair that we're going to instance. This is also very important in the world of architectural visualization. It's all about instancing and managing performance. So 3ds Max instances are respected inside of Max Interactive. Here I'm making a few instances here. I'm just going to randomly adjust their position and their rotation. And what I'm going to do is select all of my chairs and go to the Max Interactive Level Send Selected menu. And here I'm going to make sure that Update Existing Assets on top is disabled. So what this is going to do, it's not going to export 8 chairs. It's going to tell Stingray or Max Interactive, hey, you have this chair, instance it inside of Stingray based on this positional and rotational information that I'm about to give you. So I hit send. This was not sped up. That happened literally instantly because it's not exporting every single chair. And inside of Max Interactive, the performance is going to be much better because we are dealing with one chair and not 8 chairs. So if I select any one of these chairs and locate it in the project browser, you see that they are all pointing to that one chair. So just kind of to reiterate what's happening here, Stingray or Max Interactive always supported instancing within itself. It just didn't support Max instances until recently. So Max instances are respected when pushed into Max Interactive. So another thing we can do here is I'm going to go ahead and just open up my asset library. If you're not familiar with this product, it's another external product to 3ds Max. It's called the Asset Library. It's available for free on the Apps Exchange store, and it works exclusively with 3ds Max. But it's basically a way of centralizing and gathering your libraries of objects and assets that you may have. So you have this great little section of folders in here. You click on a folder, it shows you what's inside of the contents of that folder. Nice thumbnails that you can visualize these assets with. There's also multiple different ways of bringing these assets into 3ds Max. Here I'm just doing a drag and drop, so just a typical file merge. But you can also do replace. You can replace objects with objects, objects in your Max scene with objects from the asset library, et cetera, et cetera. It's a pretty awesome tool, and you can also remap dependencies. If you have missing texture maps, you can do all that via this tool outside of 3ds Max. So here we're just going to grab this radio in, we're going to bring it in, we're going to use select in place using the Y key to pop it onto the ottoman there and position it where we want it to be. And then we're going to go back into the Stingray menu, level send selected, and we're going to just send in that radio. This radio also is a V-Ray shaded material, V-Ray shaded asset. contains a bunch of V-Ray materials with, all the texture maps that come with the V-Ray material, and it's now using inside of Stingray or inside of Max Interactive the new V-Ray sort of standard material that we use when we import V-Ray materials. They get converted into the V-Ray version inside of Stingray. So next what we're going to do is just showing here that all of our maps came through, our color maps, our bump maps, and our glossiness maps. The next thing I like to do when I create projects like this, and this is kind of to sort of emphasize what we're doing here, is, we started from nothing, right? We had a Max scene. We didn't have anything in Stingray, and I want to show you how to go from Max to, from nothing to everything in a very short amount of time and in a very straightforward way. So the next logical step is to bake your lighting. It's the next thing we need to do. So in Stingray, we have a light panel, or in Max Interactive, we have a panel called light baking. In here, we're going to keep our default settings, but the two main things you want to be aware of is your light map resolution and your total sample passes. The way the Max Interactive light baker works, it's a progressive refinement solution. So it's going to progressively refine over time based on the amount of passes that you give it. It's GPU based, so the better your graphics card, the faster this will compute. And your light map resolution, or your texel per meter, is basically how big your light maps are going to be. And so the higher this number is, the more detailed the lighting solution on your objects will be, but the longer it'll take to calculate. And the heavier these maps will be on disk, because these are basically just texture maps that are applied to your objects. And so you need to be kind of conscious of the memory you have in your graphics card versus the light map resolution that you're baking at. Default settings for this scene work just fine. We're going to go ahead and hit bake, and we're going to see this progressively refine. Everything turns black, and then as objects get baked, the lighting on objects gets baked, they start to come back into view. We can use diagnostic views inside of Max Interactive to see what's going on. If I go to the view tag and I hit lighting and I hit diffuse light map texels, this is my light map resolution. This is a really great way to see, first of all, do I have any stretching on my textures for my light maps? If I had squares that were rectangles, that would tell me that I have, I'm going to have stretched light map, stretched light map solution. Or do I have a good enough density based on the size of these squares? So the bigger the squares, the lower the density, of course. The smaller these squares, the higher the density. So you want to have a pretty dense texel resolution or light map resolution. You can also adjust, because that light map resolution on the light baker is a global value. It applies to all objects, but you can go into per object basis and affect how dense the light map resolution is going to be. If I had hero objects, for example, or hero surfaces in the foreground, and background objects that I didn't want to have a high resolution, I can tone those down and bring up the texel resolution on the foreground objects as well. So here we're going to just increase the multiplier of the radio to 2, and you see that it has a much denser texel resolution. Texel resolution just refers to the squares that you see, the black and white squares on screen. So we can also visualize our actual light map solution itself. Here in this particular view here, all we're looking at is the lighting solution. We stripped away all the diffuse, all of the reflections, all of the glossiness, and this is of course a sped up version where it's kind of progressively refining. And you would just let this go until it reaches the amount of passes that you've defined. Let's go ahead and switch to a level that the light map, the lighting solution has been baked. Now you see we have much cleaner, much nicer, and this took maybe, I would say, about an hour and a half to bake out this lighting solution. So pretty good considering it's a pretty dense scene with a full interior apartment. So once you get your objects in, you get your lighting has been baked. The next thing I like to do is adjust my reflections. Just like lighting inside of a game engine, you want to, just like you bake lighting, you want to also bake your reflections. You don't want to calculate things in real time. In Max Interactive, we have something called reflection probes. We just basically pop them into our scene. These are these reflective globes. And you can kind of put them somewhat across your scene. There's lots of literature online on how to actually set these guys up very accurately. For the purposes of this particular project and this demo, having one in the living room and one in the kitchen is sufficient and is going to give a pretty good result. I typically like to put one in each room and adjust its bounding box to be just the size of the room, so it's not reflecting things on the back sides of the wall, for example. But for this is satisfactory. So we go to window, and then at the bottom of window we have lighting, and then we have bake reflection probes, we hit that, and basically it's going to go ahead and calculate what it sees around those spheres and apply those as reflection maps to the reflective surfaces around in the scene around them. So you see the result here, it looks starting to look a lot better. We're actually getting reflections from the curtains, from the environment, from things like that. Everything is starting to look a lot better. The next step that I like to do here to make things look better is to start messing around with my default shading environment. This entity or this node basically contains all of your post-screen effects, your screen-spaced ambient occlusion, your screen-spaced reflections, your blooms, your depth of fields, your motion blur. All those post-screen effects that really help to enhance the overall look of a project in the game engine is all found within this default shading environment node. So let's go ahead and just adjust these one by one. I'm going to change my sky map because I don't like, or my sky dome, I don't like the default clouds of Max Interactive. So I have an image that I've preloaded into this project of an LA skyscraper kind of image there. We can increase or decrease the intensity of that. We have bloom that we can adjust, reduce or increase the effect of the bloom. Bloom always helps add a little bit of realism to any visualization. Then we have our global lighting entry in there where we can increase the lighting brightness that we baked a little bit earlier, and also the reflection brightness is basically how I like to explain this. So we have a reflection tint, so we can increase that value to boost the reflections a little bit. We can also boost out the overall lighting solution. The next thing I like to do here is to add an automatic exposure control. So just like, exposure control in V-Ray or, any other renderer, we also have exposure control inside of the game engine. Up until recently, we had a static exposure control, meaning just one value. So as you go into dimmer parts of the scene, it wouldn't look as good. If you went into brighter parts of the scene, it wouldn't look as good. Recently, what we added was an automatic exposure control. So this basically adjusts to the lighting conditions that is found based on where you are. So if I come to dimmer parts of the scene, like behind this couch, it adjusts the exposure to better see what is around me. But of course, brighter areas in the background get blown out a bit. That's basically how an auto exposure works. We also have screen-spaced ambient occlusion. This can be also visualized as a pass in the viewport. So we can turn that on so we can see exactly what the screen-spaced AO is doing. We can half-res it if we want to increase performance. We can increase the quality, the radius, and the intensity. We also have screen-spaced reflections. This really helps add to the baked reflections that we did a little bit earlier with the reflection probes. So you bake the overall reflections around in your scene, and then you turn on screen-spaced reflections to create those contact reflections between objects. This really helps add another layer of realism to your visualizations. Of course, all of these settings that I'm adjusting, by the way, I should mention, everything that is found in the default shading environment, for the most part, these are settings we consider them to be post-screen effects, and therefore they actually do require computing time or processing time, if you will. So if you don't have such a good graphics card and you're going into VR, these kinds of things, you need to be conscious of performance, and these things will affect performance. Of course, if you have a killer graphics card, then you don't really have to be too worried about this, but just something to be aware of. All of these settings tend to affect performance to a certain extent. And there's ways of diagnosing performance inside of Max Interactive as well. Here we're turning on depth of field to show you. It's all very straightforward. You tell it where the focal region is, how large is that region, and how much are you blurring in the foreground and the background. It's a very, very straightforward way of using depth of field. All right, so up until now, what we've seen is how to bring in a project from Max into Max Interactive and how to make it look good. But the whole idea of going into a game engine is not just to make things look pretty, it's also to create interactivity. It's to be able to walk around, explore things, interact with things, move things, change things. What would be the point of going into a game engine if you couldn't do any of that? So let's take a look now at some workflows for bringing in animated objects and see how we could trigger those animations in a game engine. This is where things start to get quite fun. So we have these sliding doors here inside of Max, and you see that as I scrub my timeline, the doors open and the doors close. This effect of this animation opening and closing, we call these animation clips. So we have clip 1 and clip 2. Clip 1 is a door opening, clip 2 is a door closing. So to export these two clips, we want to be able to access these clips independently of one another. We need to do a little bit of work inside of Max. So in Max, we have something called the games exporter. This is basically a utility that allows you to export what I just described. So we're going to export the door, but we're also going to export the 2 individual clips that we can then later access independently. So here we're going to set it to export our selection, which is the door model. We're going to define our 2 clips, so open door and close door, and the frame range, right, from 0 to 100 it's opening, and then from 100 to 200 it's closing. We're going to give it a path on disk. We're going to give it a name. We're going to make sure that we're saving the clips to a single FBX file. This is very, very convenient. FBX is very clever in the way it handles this type of data. It puts everything into one single FBX file. And we're going to hit export. Here is our door FBX that we just exported from 3ds Max. This door contains everything we need. And if we had textures, they would be in there too, embedded. So now we're going to go back into Max Interactive and basically drag and drop the FBX file into the project browser down below. Doing so prompts the import dialog. In here, we're going to make sure, of course, we're bringing in our mesh. We want our geometry, but we also want animation. So we're going to enable animation. And we are going to automatically create a skeleton. That happens automatically. You don't have to do any of that. I know it sounds a little weird, skeleton, but that's basically what we call a rig. And the door is rigged because it has animation on it. And we're going to import the clips. We're going to hit the import button, and everything comes in. Everything we need from that door is now inside of Max Interactive. So we have the door mesh. We can preview it in the asset preview window on the bottom right hand. We can drag and drop it into our viewport or our level. There's our door, aligned exactly where we want it to be. We can preview our 2 animation clips. It's separated it out for me automatically. So I can preview door opening and door closing, or vice versa. And so kind of just to recap what we've done so far, we got our mesh in, we have our animation clips in. Now we want to do something with this. So in Max Interactive, we have something called Flow. Flow is a node-based environment where you basically program the behavior of things, objects, animations, effects, those kinds of things. I believe in Unreal, a similar platform is called Blueprint. So if you're using Unreal, then you've probably used Blueprint. It's a very similar approach. What I should also mention here for anybody who's curious or any kind of programmer type folks on the call or scripters, Stingray is based on Max Interactive scripting language is Lua. Lua is very similar to Python. If you're familiar with Python, then you should be able to pick up Lua pretty easily. And Flow, all of the nodes that you're about to see in here, these are all Lua based. So I can actually take this node right here and I can do Control-C to copy to Windows Clipboard and go into Notepad and do Control-V, and I would actually get the Lua code associated with this node. And I can take a snippet of Lua code and paste it also into Flow to get a node representation as well. So it's very kind of backwards and forwards compatible like that. So we have our door selected in the viewport, and we come into Flow, and we basically create a node that represents that door. This is what this green little node is here. We're also going to create 2 other nodes here called play animation clip. So we create one, and then we do a Control-C and Control-V to copy an instance out of it. Now, as you can imagine, one will play the door opening and one will play the door closing. We're going to assign them to the 2 clips that we imported a little while ago. So we're going to go ahead and just assign those 2. We can also increase or decrease the animation's playback speed using the speed value that we see there. Now we're going to tell these clips, or these clip nodes, to play that animation on the door itself, the door mesh that's inside of the viewport, or the unit as we call it inside of Max Interactive. So now we've set up the door, we've set up the clips. The clips know that they need to be played back on the door, but we haven't set up an event. Everything inside of a game engine is based on an event, right? So when do we want this animation to play back? So there's lots of different ways of doing this. There's lots of different things you might want to do. I'm going to show you one example, and that's using a volume trigger. So as you can imagine, I'm going to set up a volume, and this volume in front of the door, when I enter this volume, I'm going to make something happen. And when I exit the volume, something else is going to happen. So just like with the door, I keep the volume selected. I come into Flow, and when I right-click, I have a shortcut to create a node representation of that trigger. And as I described earlier, I'm going to say, hey, when I touch this volume trigger, when I'm inside of it, make one of the animations play back. And when I untouch it, make another thing play back. Now we can hit the green play button on the upper left-hand side of the screen to test our level, to play test our level. And you'll see that when I approach the door, I'm a person, I'm walking around, I'm a character. the door opens, and when I walk away from the door plays back closing. So it's pretty straightforward. And this is just a very simple example of how to set up animations. Now, of course, you can apply this to any kinds of animations that you can think of. This workflow is actually what game studios use to create character workflows. A character would have a walk cycle, a run cycle, a jump cycle, a crouching cycle, rather than a door open and door closed. And all those clips would be imported, and they would be set up in the exact same way. All right, so let's keep going here. There's one more workflow that I want to show you, and that's how to reuse assets. So Stingray, or Max Interactive, I'm still getting used to that term myself. Max Interactive has a really neat way of letting you share or reuse assets from one project to another. So for example, this chair here, if I right-click on it and I say, find selected asset in browser, it's going to locate that asset in my project browser. You see I can look at it through this little preview window here. What I could do with this asset is I can right-click on it and I can say export assets there in the right-click menu. This export assets will export a zip file, and all of the dependencies of this asset from this particular project will also be part of that zip. So any texture maps, any animation clips, any shader effects, anything that I attach to this asset will be zipped into that zip folder, and then I can use it in another project. So I'm going to go ahead and show you how to bring one in. So I have a fan that I exported from another project, from a different project here called Ceiling Fan Zip. I'm going to hit the import button and locate that file, and then I'm going to hit open. And you see that all of its dependencies are listed here. And I'm going to hit the import button from here and then locate that ceiling fan within my project. And all of its dependencies, the asset itself, the texture maps, the material definitions, this animation clip of the fan spinning has come through. Now I can take this fan, for example, push it into my level, attach it to my ceiling. And if I want to play back the animation clip, I'm going to right-click on the skeleton. This is just, there's lots of different ways of doing this. I showed you through Flow a little bit earlier, but I also want to show you the animation controller workflow, which is another way of assigning, more intricate animations and how animations blend between one another. You do that using the animation controller panel. I'm going to show you the animation controller with a very simple example, which is just the fan spinning on itself and having it spin on itself continuously. So we're going to right-click on the skeleton. We're going to say create animation controller. We're going to give it a name, very straightforward. And then we get this little object that appears with a character kind of running. So we double-click on this to open up the animation controller panel. And very straightforward, we're going to delete the default node that comes in here. We don't want it. And we're going to just right-click and create a new clip state. A clip state will allow us to play an animation clip on this object. The difference between doing it here and doing it in Level Flow is that in here, it will always play back even in the viewport or engine that we currently see. In Level Flow, you need to test a level to see the animation. So again, depending on what types of animations you want to do, one workflow or the other. So we're going to create a clip state, and then we're going to assign this clip state to the ceiling fan animation clip. And we are going to save it. And now you see that in my viewport, in my engine, it's always playing back. I can also go back into the animation controller and I can adjust the speed, the playback speed, so I can make it faster or slower. And what just happened there that was really, really quick is now I'm going to take this fan and I'm going to send it to 3ds Max. So I right-clicked, and in the right-click menu, there is a send to 3ds Max option. And this is going to push the fan, the animations, and the textures all into 3ds Max. So you see I have the fan here, and I'm just going to side by side these guys so you see what's happening. I'm going to just modify my timeline here so that it's only ranging from 0 to 30 so that we see the entire animation and not too much. So there you go. When I scrub my timeline, you see that I have the same animation that came from Stingray. So this is kind of the backwards workflow of going from Stingray to 3ds Max, making changes and pushing those changes back into Stingray. So the whole kind of story is very complete with these workflows. So I'm going to make an adjustment. I'm going to add a bogus propeller. Of course, an 8 propeller fan, I don't think that really exists. But the point is to show you that I'm making an adjustment. I'm modifying an asset. And I'm going to take all this, and I'm going to basically go back into the Stingray menu and hit update. I hit basically the update menu item there. Hit yes. And it just updates in Stingray or Max Interactive. Now, there's a lot of things that are happening right here for that magic to work, right? I mean, that fan is playing back in engine. It's referencing animation clips, textures, you name it, skeletons, rigs, you name it. I just took everything out of under Max Interactive's feet and replace it with something else, and it just kept going. That's really, really powerful, and that workflow works really, really great. And it's a really iterative process of building out your content with the back and forth workflows between Max and Max Interactive. All right, so we are at 11:30, pretty good on time. I'm going to keep going here because there's a couple more things there's still a few more things that I want to talk to you guys about. So what we just saw basically is some of our internal workflows, our internal demos that we've been kind of using and building out ourselves. But I do want to show you some customer work. This is a customer out in Neoscape, out in Boston called Neoscape. They are an architectural visualization firm. They focus specifically on architectural visualization, and they're a powerhouse. And they do a lot of V-Ray rendering. This is a test scene that they use to test out these workflows for us. This is a V-Ray render of that test scene. So we gave them Stingray or Max Interactive. They pushed it in via the level sync stuff that I showed you earlier, and this is how it came in. Everything came in, all the textures, all the lights, all of the materials came in. This is basically one level sync in. All we did was hit bake on the light baking solution, and we got this result that you see here. So this is practically no input. This is 3ds Max, the V-Ray scene, level sync into Max Interactive, bake lighting, boom. This is a few hours of total calculation time, but in terms of manpower, this didn't take very much time. And this is a pretty interesting result for very little input. Here's another very simple example from another customer. This is a render out of V-Ray from 3ds Max of a kitchen. We pushed it into Max Interactive, we get this result. And a couple of more shots from this kitchen scene just to show you guys some of the quality that we can get from Stingray. Really nice reflections, really nice effects here. Great metallic effects using some of the PBR shaders inside of Max Interactive. Here's another example, again, a Max V-Ray scene of a truck. We level synced it into Max Interactive. We added a few, a background, some particle dust floating around a little bit, but it looks pretty damn good. We added some interactions here to be able to open and close a truck. That was what the customer wanted to be able to do, to see how this truck would look or behave based on different modes, if you will, sort of configurator of sorts. We talked a lot about how to bring in stuff from, content from Max into Stingray. Or Max Interactive. We talked about how to set up triggers, how to make things look good, but we haven't really touched too much on VR. And I want to make sure that we get a good understanding of VR from here. So inside of Max Interactive, we have something called templates, which I'm going to show you a little bit later. You typically start off from a template. And there's different templates for different types of projects. For example, if you wanted to do a car racing experience, there's a vehicle template. If you wanted to do a VR experience, we have templates for all of these devices. So entry-level devices or passive, non-interactive type devices like the Google Cardboard, the Google Daydream, and the Gear VR. We have templates for those. And we also have templates, of course, for more advanced, interactive, immersive, truly immersive VR devices like the Oculus and the HTC Vive. So the way templates work, when you launch up Stingray for the first time, or any time for that matter, you get the project browser here, or project panel. If you go to templates, these are all the templates that you can pick and choose from. And this, by the way, is going to change in the near future. We're no longer going to have templates for different devices. It'll all be just one template, and you can output to any device from one single template. That's coming very soon. But right now in Max Interactive 1.8, this is the way it's set up. So you have templates for the different VR devices. So you basically pick the template you want, you create it, give it a path on disk, and there is a test level or a kind of museum type level or a learning level that comes with all of these templates. So if you walk around and you kind of explore, you see you have these different sort of interaction points, which I'll come to in a little bit later. But when you are ready to compile your project out, you basically go to the Deployer tab inside of Max Interactive. You give it a path on disk, you give it a name, and then you basically just compile. And then once the compilation has been done, you can go to that location on disk, and you have an exe, which is your experience that has been compiled. If I wanted to, for example, create a VR experience from a different template or for a different device, for let's say, for example, the Oculus in this case, same thing, we get a learning level in the Oculus template as well. Same thing, give it a path on disk. What I'm going to do here, though, is I'm going to point it to the same location that I outputted my original HTC Vive project from just a few seconds ago. And the really great thing is that it'll actually look at the folder content and see what it's missing for the Oculus. So that's a delta, and it only dumps in the files that it needs for the Oculus runtime. So you have one folder that will have 2 EXEs in it, one for the Oculus and one for the HTC Vive, as you see in here. So if you wanted to package this up for customers, for example, who you don't want to create 2 separate packages, you have some customers that are on the Oculus, some customers that are on the HTC Vive, you can just do one package and give it to everyone, and everyone with either device can experience it. So this is what the project looks like from a template without, you haven't added any content. This is just the learning level. What we also have is an online museum example that you can download for free. This is available for free from the project browser. You go to the online projects tab, and you have this VR Vive museum example. So if you download this guy, give it a path on disk, this is available for free, as I said, to everyone. This is basically a much more comprehensive version of what we just saw in the templates, where the templates have a learning level with 2 or 3 interaction points. This guy's got 20 to 30 interaction points. So if you play test this out, you can go anywhere you want. By the way, I need to mention that all of our VR templates include teleporting out of the box. You don't have to program or script teleporting, as is the case with other game engines on the market. So teleporting happens and is included with any VR template out of the box. You can modify the teleport functionality, the look and feel, how the teleporting works. You can, of course, change all that, but out of the box, you get automatic teleporting. So here we are, and I'm not going to let this whole thing play because it's a little bit long, but there's lots of different pedestals with different interaction points and different things that you can do. Here, we're knocking around these objects, and setting these up on your assets is very, very easy to do. You can actually just take these assets and just replace the geometry with your own to get the same behavior, or you can see how they're built and apply that to your objects. We can turn on and off gravity. We can change our wand to a baseball bat. It seems to have, so no more gravity, bats floating up. So you can turn gravity back on. There's lots of different things in this museum example. I invite you to take it, download it, use it, learn it. It's a lot of fun. And it's a really great learning experience. It makes learning how to do VR a breeze. All right, so I'm gonna keep going here because I don't want to play this whole thing, but this is actually pretty interesting. One of the nice things is this color palette that's part of the template. So you can assign colors by laser pointing them to surfaces around your scene. You can modify these materials. They don't have to be the ones that are part, of the actual object here. You can add your own materials, but this is a really great way to create a sort of space configurator, if you will, or if you wanted to. What I particularly like about VR is creating condo configurators or renovation experiences. I actually just renovated my bathroom, and I created a VR experience of it before I renovated to make decisions. We have customers that are creating condo configurators where you can choose your flooring and choose your kitchen layout, and all those kinds of things that you typically choose on paper, you can choose them in an actual real-time environment. The decision making is, of course, much better. All right, so moving right along from here, I do want to show you this quick little video. This is the apartment scene that we've been working with since the beginning, but this is the VR version of it. So just like with the templates, just like with the learning levels, we have teleporting in here. I can go wherever I want. I can experience this. This is, of course, the sort of stretched view. If you had the headset on, you would, of course, see this as if you were really in it. But here, we're walking around, we're exploring, and I want to just forward this a little bit so that we get to the part where we are changing materials on the fly, which is, really the cornerstone of VR, I think, at least in the architectural visualization space. So here we have the color palette directly from the template put into this project, and now we are assigning materials from this color palette swatch to surfaces in our scene. So this is really, really slick, and this is definitely one of the best use cases that I've seen of interactive virtual reality. All right, so moving right along from here, I'm going to try to go to the next. There we go. So we talked a lot about VR. We haven't talked too much about AR, augmented reality. That's because this is still an area of research for us at Autodesk. So we don't have too much to show just yet, but I do want to give you guys a sneak peek of some of the stuff we're looking at. This video typically has music and sound, but that won't come through GoTo or through the webinar, so just pretend you're hearing music throughout this. So if you can imagine an online virtual library of assets, all right, and that you visualize through the HoloLens, the Microsoft HoloLens. So you pick and choose this library, kind of Minority Report-ish. This is not so, it's not so in the future. This is pretty much where we're at right now with these types of devices. Now imagine being able to pick and choose from that library of assets, put it into the context of your own space and see exactly how it's going to look and how it's going to feel, how it's going to scale, its size, its proportions, all without ever leaving your space. That's pretty awesome. That's not so far in the future as you might think. This is actually possible to do right now, and this is the kind of stuff that we're looking at making, very accessible via our solutions. So keep your eyes peeled. This stuff's coming. Moving right along into Revit Live, and then I believe we're going to kind of wrap it up after this. So we talked a little bit about Revit Live at the start. So what is Revit Live? Revit Live is a few things that I want to explain here right now. So one of the first things that it is, or it's basically its biggest value, I think, is its cloud service. It's a data prep service. So we take your Revit file and we push it up to the cloud, we process it, we run a bunch of algorithms on it, we convert certain things, and we create a real-time ready version of it that you can explore, walk around, navigate, and it's completely immersive. And this is zero user input, it's one click. That lack of manual intervention that's needed is really the value of Revit Live, right? So typically you got to bring this into a product like 3ds Max, massage it quite a bit and then push it into real time. Revit Live removes the need to do that. But of course it is quite, it's not going to be the best looking example, the best looking visualization, but getting into just one click into via or into an interactive space is a pretty compelling offering. So it's a cloud service. It's also a series of applications. So we have a live viewer, we have a live editor, which I'll explain to you in a second the difference. And it's also part of a larger ecosystem that we call live design. So live design is Revit, it's Revit Live, it's also Stingray or Max Interactive, and 3ds Max. So these family of products and services and offerings are part of what we call the live design ecosystem. And these are all products and services that are connected. All right, so this is all part of the sort of connected ecosystem, connected workflow. So this is a graph showing the actual Revit Live workflow. So if we start from Revit, we push it to the cloud service that it will, create a real-time ready version of your Revit model. On the cloud, we're going to optimize geometry. These are the algorithms that I mentioned a little bit earlier. We're going to optimize geometry. We're going to reduce object count. We're going to convert certain materials because the materials that are found in Revit are not compatible with Max Interactive or Revit Live. What I should also explain is that Revit Live is based on Stingray / Max Interactive technology. It's basically running Max Interactive under the hood. It's going to animate doors for you automatically. So when you approach doors, just like I showed you earlier with the volume triggers, it's going to create those for you automatically. So when you approach doors, they will open. When you walk away, they close, allowing you to go anywhere in the model. It's going to create a nav mesh so you can walk around in spaces. And it's going to set up colliders so you can't go through walls. You can't go through the floor, right? You can walk on surfaces and collide with walls. We're going to do all these things on the cloud, and then you're going to download what the cloud produced, and you're going to visualize this in the live editor. This is one of those applications that I mentioned. The live editor allows you to make certain changes, certain adjustments to your visualization or to your experience or to your presentation, and then you can publish that to the live viewer, which can then be viewed on either VR devices, the Oculus or the HTC Vive, iPad Pros, or on Windows devices. So this is what you get when you're a live subscriber. When you subscribe to Live, you get access to the data prep service, which is where all the value really is, converting that Revit model into real-time ready. And you get access to the Live editor where you can adjust and make some minor adjustments and some minor tweaks to the experience. When you want to publish this and give this to a customer to view, they can grab the Live viewer for free. The Live viewer is free to all, but you can only view a live file, right? It's a special format that is published from the Live editor that is only viewable in the Live viewer. So let's take a look at that workflow. So from Revit, the first thing we need to do is select a 3D view. We're going to go ahead and just create one, or make sure one is created if one is not already existing. So this is a 3D view. Whatever is visible in this view is what will get published to Live. we can hit the Go Live button. Again, whoops, sorry about that. 0 user input. This will basically push your model up to the cloud. It's going to put it in the queue. It's going to process it and then download the file once it's ready. This file is then viewable in the live editor as we're about to open up here. So what you're about to see here is basically Revit Live. This is basically Max Interactive / Stingray with a slicker UI on top of it. All right. So here we can navigate, we can orbit, we can click on a surface to become a person and walk around. If I wanted to go to a specific part of my model, I can simply click on it. The system takes me there based on the navigation mesh that is processed on the cloud. I'm not walking up these steps. The actual application is taking me there automatically. As I approach doors, they open. And when I want to go somewhere else, I basically click there to fly. I have the arrow keys that I can use to walk around as a person. And all of my Revit views are available on the right-hand side here, as you see. These are all the views that I've defined in Revit. In Revit Live, I can swoop to any view by clicking on it. And I can delete views. I can reorder views. I can rename views. I can create new views from Revit Live. What we also have here are pins to display those views. So I can click on any one of these pins to basically fly there, just like as if I touched the thumbnail itself. I actually like to take them off. I don't particularly like the pins, so I hide them. And then I can hit orbit to go back into this kind of flying mode where I'm God and I'm navigating around this mesh. You can also turn off all your textures to just show massing if that's something you want to be able to analyze. And what I should also mention is that Revit Live is a pretty interesting tool in that it's a really great presentation tool if you want to create nice presentations. This is a pretty good job. This does a really good job. We have a present tool on top. But it's also very valid to use Revit Live as an actual design review tool. We have customers that are doing that a lot. They're actually leveraging this experience to make design decisions at any stage of the design process, because you can process a file on Live anytime. Right, and you can analyze things and experience things and understand things in ways that you just really can't from a static image or a static 3D view in Revit. So it's pick your poison. It can be a presentation tool, but it can also be a very valid design review tool. So we can adjust the time of day. This is based on Revit data and the day of the year. We can also turn on and off our artificial lights with the L key. All of our BIM data as well came through. If I turn on the info key and select any one of these surfaces or families, you see that I get all the BIM data coming through. And once I'm satisfied, I can also hit the present button, and basically this jumps into this presentation mode where I can cycle the views using these arrows. And then also VR is a really big deal. We talked a lot about VR today. Revit Live supports VR right out of the box. I'm just going to forward to that section right there. We have a VR button at the lower right-hand side of the screen. VR, it's no longer beta, by the way. We support HTC Vive, as I said, and the Oculus out of the box. The Oculus now has controllers, no longer uses the Xbox controller. You basically hit the VR button. If your device is connected, it jumps you right into VR. Zero configuration, zero setup. You're in VR with one click. So if you think about it, Revit's Revit Live to VR is 2 clicks. So you got VR from Revit in 2 clicks. And that's pretty slick. And all of the built-in functionality happens out of the box. Teleporting with this very slick laser. We have a little mini map that's pretty cool. So if you can turn on the mini map, you basically fly out and become God looking at your project. You can tumble it around, you can move it closer to you, move it away, and you can laser point anywhere inside of the map to zoom into that location. Once you're done with VR, you hit the escape key and you're out of VR, right? So in and out of VR also really, really powerful. Not many can do that, and we do it really well. So why Revit Live? Just to summarize, very quick to get into an interactive experience at any moment of the design process. 1 or 2-click virtual reality, really. You maintain Revit's BIM data, and you have a path to enhance this via 3ds Max and Stingray. Because, again, to reiterate, this is based on Stingray / Max Interactive technology. So that what you just saw in Revit Live can be pushed into Max Interactive, and then you can use 3ds Max to bring in animated assets, and you can create really killer experiences. So I'm not going to go through this whole section here because we are kind of running out of time. But I do want to wrap up with this particular slide here. So this also has a little bit of music, so you won't be hearing it, but basically VR and AR are a really big deal for Autodesk. We are heavily invested in this technology. We are setting up labs across the world. I want to give you guys a quick little video of the lab that we just set up in Munich, in Germany. It's pretty slick.
Autodesk's Virtual Reality Center of Excellence in Munich, Germany is now open. Our vision is to have a room where virtual, augmented, and mixed reality can easily be explored in real time. By using the newest software and hardware, we were able to dive into 3D models and evaluate them, regardless of which industry you represent. Imagine walking freely around your products, configuring any aspect you want.
So this lab actually contains pretty much every modern form of AR, VR that you can think of. It's got HTC Vives, Oculuses, Microsoft HoloLens technology. It's even got the Google Tango, and all of our products that have some sort of VR or AR component are also represented in here. So there's other things beyond, game engine. There's Red, which is an automotive visualization tool, also ties into VR and many other products and services. And everything here in this lab is basically around these technologies. So I'm not going to let this whole thing play because I know we're running out of time and we wanted to answer some questions, but I did want to give you guys a quick little sneak peek of, this is one lab, there's many others that are opening across the world. So keep your eyes peeled. VR and AR, big deal for Autodesk. Oh, there we go. So with that, I'm going to thank you very much for attending the webinar. I hope you got value out of this and I hope you enjoyed it.